Okay, guys. So I wanted to go over permutations that we did this week. That has to do with probability and the ways that you can arrange certain items. Okay. But before we go into that, I want to review counting principles. This was the principle that we talked about when we did the Desmos activity over Chipotle. Okay. We found all the different options for the entrees you can make for Chipotle, and to figure out all the different meals you could make there, we just took all the possible options and we multiplied them together. It's the same thing with this IXL. They are hiring teachers for a science department of a new high school. There are 9 biology teachers and 8 chemistry teachers to choose from. How many different ways can she hire a biology teacher and 1 chemistry teacher? Well, there are 9 and 8, and 9 times 8 is 72. That's all you need to do. Find the numbers. Here, 2 types of meat, 5 cheeses. How many different sandwiches can they do? Well, 2 times 5 is 10. Okay, so to find all the possible combinations, just find the different options, the number of those different options, and multiply that number together. The same thing is fairly true for permutations. Okay. Now, a florist is working on a wedding bouquet that uses 5 different types of flowers. And how many different orders can the various types of flowers be added to the bouquet? Well, to really look at this, let's make it a little bit simpler. Let's say there's 3 flowers. Okay. There's a red flower, a blue flower, and a green flower. Okay. So let's look at all the different ways where we can arrange 3 flowers. So let's say we start with the green one first, and I'm just going to put lines for the flowers. Okay, well, let's say red's next in this one. Red's over here for this one. And then red will be first for this one. And for this one, and red will be here. And red will be here. Blue, 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 blue first, and blue first. So there's all of our possible arrangements. Green, red, blue, green, blue, red, red, green, blue, red, blue, green, blue, green, red, blue, red, green. I'm pretty sure I got them all. Okay, and you can see that there are 6 possible arrangements of those flowers. Well, how can we do that without drawing out every single one? Because once I start to get up to 5 flowers, it's going to be a long list. Okay, well, if we think about it, for our 3 flowers, there are 3 spots to fill. For this first spot, I have 3 choices. Okay, I can put 3 different flowers in that, either red, blue, or green. All right, let's say I want to put my red one here. All right. Now, when I go to my next one, I only have 2 choices left because I've already put one of my flowers down. So I only have 2 flowers left. So let's say I put my green flower here. All right, and then finally, that means I only have one choice left for the very last spot, which is where my blue flower needs to go. And remember, from our counting principles, if we take the possible options for each choice and multiply them all together, we'll get the total number of possible combinations. Well, I have 3 choices for my first one, times 2 choices for my second one, times 1 choice for my last one. 3 times 2 is 6, 6 times 1 is 6, which is the same number of stuff we get here. So when you do these, you're really just multiplying the number of types that you have. So in this case, we'll start at 5, and then you're just counting down by 1. In this case, we would do 5 times 4 times 3 times 2 times 1. And you actually end up with 120. Of course, it didn't register because I wasn't signed in. All right, so this one, 4 times 3 times 2 times 1 would give me 24. Okay, now you're probably saying, oh, well, I have to multiply every single number counting down by 1 every single time. No, there's a handy little thing called the factorial. Okay, so if we wanted to do 5 times 4 times 3 times 2 times 1, we could just do an exclamation mark. We call that a factorial, and that does exactly the same thing. 5 times 4 times 3 times 2 times 1, you'll notice gives me the exact same thing, 120. Okay? So for these first few on here, you just need to basically count the number of items and use that number factorial, like this one. 1 is a pair of pliers, 2 pair of safety goggles, 3 is a screwdriver. So we have 3 items that we need to order. So 3 exclamation mark 6. Okay. As you move up in this, though, it gets a little trickier because there will be more items than there are spots. Okay. What I recommend for this is use a piece of paper and draw up the spots. So this says there's 10 students going to the library to work on homework, but there's only 2 available computers. So how many ways can we fill in those 2 spots? Okay. Let's imagine here's the 2 spots. All right. For the first spot here, we have 10 options. Oops, pen. Okay. Now, once someone sits in that seat and we choose them to sit there, they're not going to sit in the second seat. We're going to have 9 options to sit in that second seat. Okay, I filled up all the seats. Now we need to take, just like our counting principle, our number of options and multiply them together. That's all you have to do. Find the number of items you want to arrange, how many spots you want to fill. Just make those spots, start with your number of items, and count down. This one becomes 3 times 2. Okay? All right, guys, that's it for today. Let me know if you guys have any questions, shoot me an email, or just save it for next week in class. All right, have a good weekend.